Hey guys, I'm back with a new video. In this video, let us learn about binary trees. Now in the previous videos, we learned about the linear data structures like arrays, linked lists, stacks and queues. So in this video, we are going to cover about trees, which are hierarchical data structures. Now let us understand what a tree actually looks like, and then we'll understand the terminologies revolving around trees. So a tree looks something like this. First we have the root node. So this is known as your root node, and this is the topmost node of the tree. Then the elements that are directly under a node or an element are called its children. So these three nodes are basically the children of the root node, and they are the direct children of the root node. Now the element that comes directly above something is called the parent node. So if I say this as 1, 2, 3 and 4, so 2, 3 and 4 are direct children of the node 1, and 1 is the parent of nodes 2, 3 and 4, right? So you can say 2 is the child of 1, 3 is the child of 1, 1 is the parent of 4, 4 is the child of 1. Finally, the elements that are having no children are called the leaves or the leaf nodes. So these three elements are called the leaf nodes for this tree. Now let me draw one more tree. In the general case, you can see that any node can have any number of children, right? So you can go on extending it as further as you want. Now here, if you see, this is your root node, and the nodes that are having no children are called as the leaf nodes. So the leaf nodes are, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is your root node. So now let us move forward and understand the concept of binary trees. So now we know what a tree is. Let us understand about binary trees. Now a binary tree is a tree whose elements have at most 2 children. Now this node can have at most 2 children. So let us take one child, and this is also a binary tree. If you take 2 child for this node, this is also a binary tree. Then a single node with no children is also a binary tree. So all these are binary trees, right? So 1, 2, 3, 1, 1, 2 and 1, 3. Now as you can see, each element in a binary tree can have only 2 children. We typically name them as the left child and the right child. So this is the left child for 1, left child and right child. 3 is the right child of 1, 2 is the left child of 1 for this tree. For this tree, 2 is the left child of 1, and for this tree, 3 is the right child of 1. So now we know what a binary tree is. Let us move further to understand the properties of binary tree. Now let me draw a simple binary tree, and then taking that as an example, let us understand the properties of binary trees. So let me draw this 1, 2, 3. So here you can see each node can have at most 2 children, and then for 2 let us say 4 and 5 and 6 and 7. So this is our binary tree. Now taking this binary tree as an example, let us understand the properties of binary trees. Now the very first property is that the maximum number of nodes at a level m of a binary tree is 2 raised to the power of m, which means that the number of nodes at max on level m of a binary tree is 2 raised to the power of m. Now let us understand this with the help of this binary tree. Now for the root node, the level is 0. So let me take m as the level. So level is 0 for the root node. Now the number of nodes on level m using this property at max can be 2 raised to power 0, which is 1. And you can see we are having one node at level 0, which is the root node. Now let us move forward to level 1. So this is our level 1, or you can say m as 1. Now for this node, the number of nodes at max on level 1 will be 2 raised to power of m, which is 2 raised to power 1. So 2 nodes, which are namely node with a data of 2 and node with data of 3. And here you can also see that in a binary tree, every node is having at most 2 children. So if you take 1 into account, it can have at most 2 children, 4 can have at most 2 children, 2 can have at most 2 children, 3 can have at most 2 children. If you want to extend the binary tree further, you can give at most 2 children to 4, but here you can see 4, 5, 6 are having no children, so these are the leaf nodes. Here you can also see that the next level will always have twice the number of nodes that we are having in the previous level. Now since in the previous level we are having 1 node, then in the next level we are going to have 2 nodes. And then if we move further to level 2, we will have twice the number of nodes that we are having in level 1. So 2 into 2, which is 4. And if you apply this formula for level 2, so the number of nodes at max on level 2 will be 2 raised to power 2, which also gives us 4. So in total you can see we are having 7 nodes. So at level 0 we are having a node, at level 2 we are having 2 nodes, at level 3 we are having 4 nodes. So in total 7 nodes. Now let us move forward to the second property. So properties of binary trees. Now let us draw back the same binary tree that we took as an example. So 1, 2, 3, 4, 5, 6, 7. Now the next property is that the maximum number of nodes in a binary tree of height h is 2 raised to the power h minus 1. Now before understanding this property on the given binary tree, let us first understand the terminology, which is the height of the tree. Now height of a tree is maximum number of nodes en route to leaf path. That is, if you take 1 and 4, what are the maximum number of nodes on the path from 1 to 4? So let us see this path. So on the path from 1 to 4, you can see we are having 3 nodes, right? Therefore, the height of the tree must be 3. And here we are taking the assumption that the height of a tree with a single node is considered as 1. So if you take just this node, which is the root node 1, so this is at height 1. If you take 2, this is at height 2. If you take 5, this is at height 3, which is same as for 4, and 6 and 7 as well. So 6 and 7 are also at height 3. And since we are not having any more nodes after this level, therefore the height of the tree is 3. Now as a side note, a tree has maximum number of nodes if all the levels have maximum nodes. So maximum number of nodes in a binary tree of height h comes out to be 1, and for this we are having 2. Then for this we are having 4, and let us go on till 2 raised to the power h minus 1 for a tree that is having a height of h. So this is the general case. Now this is a very simple geometrical progression with h terms. So let us use the formula for geometrical progression: a r raised to the power of n minus 1 upon r minus 1. Now here r is the common ratio, so the common ratio is 2, and the number of terms, which is n, is small h. So let me put the values, and a is 1, so 1 into 2 raised to the power h minus 1 upon 2 minus 1, which gives us exactly the same formula that we discussed. Now let us go to the third property, which says that in a binary tree with n nodes, the minimum possible height is log n plus 1 base 2. Now here you can see in this binary tree we are having 7 nodes. So if I put the value of n as 7, so log base 2 7 plus 1, this gives us log base 2 8, and 8 can be written as 2 raised to the power 3. 3 comes as the coefficient, so 3 log 2 base 2. And from the property of logarithms, we know that log of something to the same base is 1. So this comes out to be 3. And here you can see that the minimum possible height is 3. Now let us move forward to the fourth property. But before that, let us clear up some space. Now the fourth property is that a binary tree with m leaf nodes will have at least log m base 2 plus 1 levels. So at least these many levels will be there in a tree that is having m number of leaf nodes. So we are talking about binary trees. So let us verify this. So here you can see we are having 4 leaf nodes. So log 4 base 2 plus 1, which is 2 plus 1, which says 3 levels. So this is level 0, level 1, level 2. So we are going to have at least 3 levels, though we can use more levels as well, but at the minimum we are going to have 3 levels, right? So from this we can conclude that a binary tree has maximum number of leaves when we have minimum number of levels. So the minimum number of levels is 3. So if you have the minimum number of levels, then you will have the maximum number of leaves, which you can see from this case, because here all our levels are filled. Now finally, let us discuss about the fifth property. Now fifth property is that consider a binary tree where every node has 0 or 2 children. The number of leaf nodes are always going to be 1 more than the number of nodes with 2 children. So the number of leaf nodes in this case is 4, and the number of nodes with 2 children, so this is the abbreviation I'm using, nodes with 2 children, right? And here you can see 1 is having 2 children, 2 and 3, 2 is having 2 children, 4 and 5, 3 is having 2 children, 6 and 7. So the number of nodes with 2 children are 1, 2 and 3. So in total we are having 3 nodes that are having 2 children. So the number of leaf nodes are 4 and the number of nodes with 2 children are 3. So from the property you can see 4 is equals to the number of nodes with 2 children plus 1, which is true. So this property holds good as well. So this was all about the video where we discussed what trees are. Then we discussed about binary trees and their properties. So in the next video, let us discuss about different types of binary trees. So let's catch up in the next one.